The formula sheet for the methods exam came out last week, and a couple of interesting things. So I was pleased to see a new entry for binomial distributions that included the formula to work out the probability that the random variable takes on a certain value. So that was this one here. So in previous years, that has not been given. Okay, that was expected to be either in your notes if it was in exam 2 or memorized if it was on exam 1. And recall that the mean is equal to the number of trials multiplied by the probability of success, and sigma squared was equal to the probability of success multiplied by the probability of failure multiplied by the number of trials. So yeah, it was good. Like that. It's good to see that one. That one came up in exam 1 a few years ago, and one of the things the examiners mentioned is that it was evident that students didn't know this formula. But what was a little unexpected was this thing here, the Bernoulli distribution. So I was just expecting to open it up and go, all right, yep, business as usual. And then I saw this one here. So it's nothing to be alarmed at. In fact, I think if we look at it and heat it, it could actually be a fairly easy mark to grab. So what is the Bernoulli distribution? So I copied this off a little bit of literature that's coming around the head of maths forums at the moment. So the Bernoulli distribution is the discrete probability distribution of a random variable which takes a binary Boolean 2-option output. I put the 2-option thing in. 1 with the probability P and 0 probability 1 take P. So there's 2 options, all right? And this one here, whatever this is, this might be the chance of getting ahead. We've got the probability of success there, and tail, probability of failure, 1 take P there. Okay, so they're your 2 options. And we call a success in terms of Boolean terms. Success is called a 1, and 0 is called a fail. So you're running an experiment which might lead to either success or failure. You can associate it with your success labeled with 1, a probability P, while your insuccesses labeled with 0 have a probability of 1 take P. Right, so that's what this essentially is. It's the distribution of that particular thing. So the probability that the random variable takes on a particular value here, either 1 or 0, if it's 1, then it's going to be the success. If it's 0, it's going to be the random variable is going to equal the fail. Right, so let's have another or a longer look at it. So this is the probability function associated with it. So I've just ripped that off there and pasted it in. The probability of success P is the parameter of the Bernoulli distribution. And if a discrete random variable X follows the distribution, we write this, we define it. So just like in the notes we're writing, X is a binomial variable, number of trials, probability of success. We write this as X is a Bernoulli, all right, with the probability of success, whatever it is, 0.4, 0.6. So here is the Bernoulli distribution for an experiment where the probability of success is 0.72. Yeah, here it is, rather uninspiring. All right, and so we'd write it as X is a random variable that is a Bernoulli distribution, probability of success at 0.72. So here's the distribution here, and we get a 1 is 0.72 and a 0 is 0.28. Right, since it's the only trial being done, the expected value is, or the chance of success is 0.72. So hence, mu, or the expected value, is P. Note that we don't multiply by n, so note the difference between the Bernoulli trial and the binomial is that we don't multiply by n. We just say that the expected value is the probability of success. And what I'm expecting is it's the same thing with the variance. So we simply multiply P by 1 take P, and we don't need to multiply by the number of trials. Okay, so yeah, calculation of variance is the same as the binomial distribution, except we don't multiply by n, again, because it's done once only. So this is, again, representing one trial only. All right, remember that when we do the experiment many times, say n is equal to 10, we start to get this distribution where the probability of success is 0.25. This thing here is much more meaningful to me. If you show me this one here, I'd just go, whoa, big deal. But they've put it on the formula sheet, so we need to sort of have a look at it. So how could it be assessed? This was from one of the chief examiner of exam 2. So she obviously wrote this question. A netball player has, or was based on, I've changed it a little bit. A netball player has a probability of 0.4 of scoring a goal each time she attempts to goal. She takes one shot at goal. Calculate the standard deviation of the number of goals she shoots. And I said here, let's be a little crazy and say that this is 3 marks. All right, well, the first thing to note is that she takes one shot at goal. So let's define what we've got. X is a Bernoulli trial where the probability of success is 0.4, 1 mark. All right, now what we're going to do is note that the formula for standard deviation, well, what standard deviation is? Standard deviation is sigma, okay? So what we're going to find is sigma squared, all right? We want the variance. Now the variance, sigma squared, is equal to P multiplied by 1 take P. All right, so let's get it. Sigma squared is equal to 4 over 10 times 6 over 10, which is equal to 24 over 100. And then what I'm going to do to find sigma is root both sides, and that's going to give me root 24 over 10, which is root 6 times root 4, 2 root 6 over 10, which is 6 root 5. Okay, so there's our 3 marks there. So I think maybe an extra mark for getting sigma squared. Okay, and probably want to make sure that that's simplified. What's that? 12 over 50, 6 over 25. And then my final mark for getting the standard deviation. If you ask me what that means in terms of standard deviation and spread, I'm not sure really what we can conclude about the standard deviation, but it just shows the spread of values around the mean or around the expected value. So our expected value is 0.4 and the standard deviation is root 6 on 5. So that's, something like 2/5, about 0.4 as well. What is it? So let's find out. Shift root 6 over 5. Yeah, 0.5 roughly. So my thoughts, it seems a bit odd, but given they've put it on the formula sheet, my feeling is not if it comes up, but when it comes up. Okay, so the fact that they've made an entry into it means I feel like they're just sort of saying, hey, like, heed this. This is something that's important here. Otherwise, we wouldn't be saying it. But in real life, a single trial really is not going to tell us much. We're going to do that trial several times and get the binomial distribution. So this is where I think the important stuff is. Okay, the Bernoulli itself, the single trial, doesn't mean much to me, but let's hope VCAR do write something similar to what the chief examiner put out there, because that's a fairly easy couple of marks on that.